All right, so today we are learning, we're doing Unit 2, Lesson 12, and today we're going to learn how to divide polynomials. We've done adding, we've done subtracting, we've done multiplying using the box method. Today we are going to talk about dividing polynomials. And to divide, we are actually going to use the box method, but the box method in reverse. And the reason we're going to do that is because of how multiplication how multiplication and division are related. So for example here, if I take a division problem that everybody knows, for example, 20 divided by 2, we of course know that that answer is 10. The reason that 20 divided by 2 is 10 is because 10 times 2 is 20, okay? The reason why, 24 divided by 4, okay? 24 divided by 4, we of course know is 6, and the reason that that is true is because 6 times 4 is 24. So the way we're going to think of division is, for example, let's do another one. Let's say 30 divided by 5. Now we know that answer already, but to figure out what our actual answer is, we're going to figure out 5 times what number is 30. And we, of course, know that 5 times 6 is 30, which is why the answer is 6. We're going to take that same approach. When dividing polynomials. So in other words, what do I need to multiply the denominator by to get the numerator as an answer? Okay, so, and we're going to do that by using the box method. So our first example right here, okay, instead of doing the pure division, we're going to figure out what do I need to multiply x minus 3 by to get this polynomial. So in order to do that, we're going to set up the box method. So the setup, the denominator goes along the side of the box. So I'm going to set up the box method. Okay. Now we don't know how long the box is going to be yet. So I'm just going to leave it like this. So I know that I'm going to put the denominator along the side, x minus 3. That's what that means. The top of the box is left blank. So we're going to leave, and let me use a different color here. We're going to leave what we would normally put here. We're going to leave that blank because I need to figure out what needs to go here so that when I do the box method, I get 2x cubed minus 3x squared, so on and so forth. So I'm going to leave the top of the box blank. Let me change my color back here. The numerator is the answer when we're multiplying. So we're going to figure out what goes on top of the box so that when I multiply, I get the numerator. So the top left of the box is going to be, you're going to put the first term of the numerator. So the first term of the numerator is 2x cubed. So I'm going to put that in the first spot of the box. Okay. So we of course know that if I were to multiply x times whatever is supposed to be here, I get an answer of 2x cubed. That is how the box method works. So my question is, x times what is going to equal 2x cubed? All right. Well, we of course know that it's going to be x times 2x squared. Right? Is x times 2x squared equal to 2x cubed? And the answer is yes. So that is how we're going to do this. We're going to work from left to right the leftmost column to the rightmost column. The diagonals should add to the next term. We're going to repeat this process until you're down to the constant term. Okay, so I figured out that x times 2x squared is 2x cubed. So now I know what goes on top of the first column. Now, once I know what goes on top of the first column, I can now go ahead and finish column 1, because x times 2x squared is 2x cubed, and negative 3 times 2x squared, if I multiply that, that's going to be negative 6x squared. Okay? So I've actually done the first column. I figured out what goes on top of the first column. Now I'm going to move on to the second column. Now I'm going to move on to column 2. Okay? So we know that when we do the box method, we know that these diagonals represent our like terms. So I know that I need to have negative 3x squared. But down here, I already figured out I have negative 6. So what do I need to put here so that when I combine these like terms, I get negative 3x squared? Okay, and the answer is I need to put positive 3x squared here. Why positive? Because if I combine negative 6 and positive 3x squared, do I get negative 3x squared? I do. All right, I'm going to literally do the exact same thing I just did. Okay, so I'm going to repeat the process now that I just did in column 1. So now I need to figure out x times what is 3x squared? X times what is 3x squared? And the answer is x times 3x. So x times 3x is 3x squared. So now I've figured out what goes on top of the second column. I can now go ahead and finish the second column. X times 3x is 3x squared. Negative 3 times 3x is going to be negative 9x. Okay? Now, keep in mind, in the directions, it says we have to repeat this until you're down to the constant term. Now, we're not down to the constant term yet, so I know I'm going to need to add at least one other column here. All right, so I've done the second column. Now I'm going to do the same thing I just did. So I already have negative 9x here, but I need negative 19x. So what needs to go in this spot so that when I combine these like terms, I get negative 19? And the answer is I need to put negative 10x here. Negative 10x and negative 9x is negative 19x. And now I'm going to do this one more time. So x times what is negative 10? And the answer is negative 10. Okay. X times negative 10 is negative 10. Okay. And then negative 3 times negative 10 is positive 30. And notice I got a constant term of 30. And notice it matches up with the constant term of 30 up here. So I know that I'm done. So I've done all of this. What is my answer? My answer is this right here. So when I divide these two polynomials, the answer is 2x squared plus 3x minus 10. That is the answer. Okay. Let's look at number 2 now. Okay. So now notice I have a trinomial in the denominator. That's why I wanted to do this, which means I'm going to need 3 rows when I set up my box. Oops, I forgot how to draw here all of a sudden. All right, so I'm going to remember I put the denominator along the side of the box. So x squared minus 8x plus 15. Okay. I put the first term of the numerator in the top left. So x cubed. And now I'm going to do the same thing I just did. So what goes up here? X squared times what is x cubed? Okay, and the answer is, of course, x. X squared times x is x cubed. Once I know what goes on top of that first column, I can go ahead and finish the column. So x squared times x is x cubed. Negative 8x times x is negative 8x squared. And 15 times x is 15x. Okay. Now I'm going to look at this diagonal. All right. So notice I have negative 8x squared, but I know that I need negative 9x squared, which means I need to put a negative 1x squared here, right? Negative 1x squared and negative 8x squared becomes negative 9x squared. Now I'm going to repeat this. So x squared times what is negative 1x squared? Well, it's going to be x squared times negative 1, right? Is x squared times negative 1 equal to negative 1x squared? And the answer is, of course, yes. All right? So let's finish out this row here. All right, let's finish out this row. Negative 8x times negative 1, negative times a negative, that's going to be a positive 8x. And 15 times negative 1 is going to be negative 15. Okay, and if I check to make sure these add up correctly, is 15x and 8x equal to 23x? Yes. Now I'm down to my constant term down here. Did I get the correct constant term? Yes, I did. 15 and negative 15, so I know I'm right. So what is the answer? The answer is x minus 1. All right. Let's do the third one. What do we notice what's different about this one? Notice my numerator is 27x cubed plus 64. Notice I'm skipping. Not only is it a binomial, it has two terms, 27x cubed plus 64, but also notice that I skipped some exponents. I started out with an x cubed term, but I don't have an x squared term and I don't have an x term, okay? In my first two examples, I had an x cubed term, an x squared term, an x term, and a constant term. Same thing with number 1. I had an x cubed term, an x squared term, an x term, and a constant term. Here I skip that. So because of that, I have to account for it. I have to account for missing exponents. So watch how I rewrite this here. I'm going to rewrite the problem like this. Okay, notice what I did. Notice I accounted for a missing x term. I wrote it as 0x squared. Same thing here, plus 0x. So this is something that was not in the lesson notes that I would suggest writing in your notes. If you have missing exponents, you need to account for those missing exponents with a 0. So plus 0x squared plus 0x plus 64. Now I can go ahead and I can now go ahead and use the box method. Okay, so I can take my denominator, put that along the side of the box, 3x plus 4. Take the first term of the numerator, 27x cubed, put that in the top left, and now I'm going to do my thing. So to figure out what goes here, 3x times what is 27x cubed? So let's look at the whole numbers. I know that 3 times 9 is 27, right? And I know that x times x squared is x cubed. So 3x times 9x squared is x cubed. So what goes on top of that first column is going to be 9x squared. 3x times 9x squared is 27x cubed. Okay, now I'm going to finish out the first column. So 4 times 9x squared, that's going to be 36x squared. Okay. Now I'm going to look at the diagonal. I have 36x squared, but I need 0x squared. So in order to get 0, I need to make this a negative 36x squared, because 36 and negative 36x squared will cancel out and you'll be left with 0. All right, now I'm going to do the same thing in the second column. So 3x times what is negative 36x squared? So if I look at the whole numbers, 3 times what is negative 36? That's going to be 3 times negative 12, right? 3 times negative 12 is negative 36, and x times x is x squared, so negative 12x. All right. Now I'm going to finish out the column. 3x times negative 12x is negative 36x squared. And then negative 12x times 4, that's going to be a negative 48x, right? 4 times negative 12 is negative 48x. Okay? Now look at the diagonal. Once again, I have negative 48x, but I need 0. So to get from negative 48, so I have to make this 48x. I have to make this 48x in order to get 0x, right? In order to combine that. Now I have to do this one more time. So 3x times what is 48x? That's going to be, let's see. Excuse me. Whoops, wrong color. So 3 times what is 48? So we know it's going to be a positive. It's going to be 16, I believe, right? Is 3x times 16 equal to 48x? And the answer is yes. So now I can go ahead and finish out this column and do 4 times 16. 4 times 16, if I did it right, should be equal to 64. And 4 times 16 is equal to 64. So I get the correct constant term. So I know that this right here is the answer. 9x squared minus 12x plus 16. Okay, so your cool down is just going to be using this process, using this reverse box method process in order to divide polynomials.